So my name is Fernando. I'm CTO at Zeta Alpha. I'm joined by...
And I'm Eric Pugh. Some of you you guys know who I am. And I'm super excited about this talk. And this talk is a little different than maybe some of the other talks that you've seen here. Most people's talks, they're coming here to show you something that's very polished, an in-production idea, something that's in production, something that's been proven. We're here maybe to share more of an idea and an experiment and a project or a POC that we've been working on for the last few weeks or months. And the genesis of this talk, and you're going to want to look up Stavros, the genesis of this talk was back at OpenSearch Con Europe in Amsterdam, right? Some of you may have been there. And Stavros and I gave a talk on eyeballing, being able to look at individual search results. And it was a great talk, and it was we really enjoyed it. You can tell we're having a good time up there. And then I had the opportunity to take a couple of days and go bike riding around the Netherlands. I went and saw some windmills. I took my little pet moose that I take photos of for my children and had a couple of days to think about some of the ideas at the conference. And one of the people that I met at the conference is my co-presenter here, Fernando. And him and I, after I went bicycling for a couple of days, we met at Zeta Alpha's offices in Amsterdam on a Saturday of a national holiday. So I very much appreciate Fernando taking his Saturday of a national holiday, it was King's Day, and going in. And we spent the day talking about some of the topics from the conference. And Fernando really had this idea. I was supportive of it. And his idea was, what if we combine the evaluation power of RAGElo, a tool for measuring RAG solutions, with the eyeballing power of Search Relevance Workbench? Now, how many people have seen Fernando speak about the RAGElo project? A couple maybe, yeah, okay. Well, we're gonna talk a little bit about what that project is. How many people saw Stavros and I talk yesterday about Search Relevance Workbench? All right, so need less introduction on that topic, right? And so what we're here to share is not a polished answer and you should use this, but more the results of what we learned, and we're looking for feedback from you all on, would this be useful to you? So I'm gonna hand the cursor over.
I mean, many companies these days are trying to get the value of Gen AI, and everybody agrees that everything is kind of hidden behind the organization's internal data, but you will not want to put some solution out there without first checking that it behaves the correct way, right? So in order to do that, you need evaluation. And evaluation can become tricky, so I want to take you through some history first. So imagine you are back in 2022, very long time ago.
Back to 2022.
RAG systems will look like this, right? So you have a user query. You will send the user query to a vector search, and then send the response with the original query to an LLM to get an answer. If that didn't work, what you could do there is maybe change the prompt. Back in the day, LLMs were very sensitive, so you will need to say things step by step, or take a deep breath, or maybe change the way you chunk the documents, or maybe change the model. So there was some variation there. Now that I'm talking about this, I think it's my duty to set the record straight. So RAG doesn't need vector search, and it was just the simplest solution back then because you could actually send the same query to the search engine as well as to the LLM. But these days, it looks something more like this. So you have a user query, and then the LLM will decide which tool to use based on a predefined set. That can be, stuff like a BM25 search, vector search, maybe hybrid, and the LLM may be able to decide what to use based on prompts, right? So if that is not working as well, what you can do here is adjust the prompt of the LLM, maybe change the tools you are giving it to it, and as well as changing the the final prompt. Now, if you think about more complex agentic behavior, it would be something like that, where you have big agent orchestrator that has access to not only search tools, but also external APIs, web browser, and so on. It can delegate tasks to other agents that may be predefined or like actually created in real time by the orchestrator. And each of these agents will have a similar architecture as the original orchestrator, right? So it's very, very complex. And there are so many prompts that you can tweak. And there's going to be memory, and then how the agents will communicate to each other. So the number of variations you can create with this architecture is very vast. Mm-hmm. So the problem then is that you can very easily prototype. I mean, there are many tools, open source tools, for creating these agents. But how can you evaluate that, right? So as I mentioned before, several variations from the ingestion pipeline to the retrieval pipeline, the agent architecture can change, the LLM choice, and so on. And when you're trying to work with enterprises, the way evaluation will work there is that, I mean, of course, you can try to eyeball the solution as search engineers. And at Zeta Alpha, a lot of us have PhDs and master's degrees. So, we think we can do it, but in reality, we don't have like the deep expertise as the real experts here. So the way it typically goes is that you maybe give 50 to 100 queries to an expert. They will probably just complete one or two. So we can use that, refine the agents, come back to them, and maybe if they're really into LLMs, they might try again, or maybe they would say, well, sorry, I'm too busy, stop bothering me. So that's a problem, right? Because if you cannot really understand whether the agent is functioning correctly, how are you able to deploy this, right? Mm-hmm. So kind of naturally, you may think, since LLMs, well, some people claim that they have a PhD level intelligence, why not ask the LLM to evaluate it, right? So in this case, it's the same setup as before, but once you have the answer, you can configure another agent or prompt to look at it, maybe take into account the accuracy, the relevance of the results, and so on, and say whether the answer is good or not. When you do that, though, you will realize that, okay, after changing the variations of the RAG system, you will see some different levels of quality. But when you compare it with human annotations, I think it's not working. It will look more like this, right? So LLMs are a bit too optimistic, and they will kind of agree with you, and then try to find some way, like tangentially, it kind of relevant. And the thing we discovered through empirical observations is that if you actually sort the variations from like lowest quality to highest, there seems to be some correlation, right? So this is saying that both the LLMs and the experts agree that the worst performing system is on the one on the left, and the best performing system is one on the right. So based on this, you could ask, and we have tested that across many domains, and we see this agreement, at least empirically. So you may ask, okay, should we then just ask the LLM to compare two answers instead of one, right? Given that it's very good at distinguishing between pairs. Oops, sorry. So the setup here will look like this. So you have two versions, therefore two versions of the RAG system, therefore you have two answers. And then you will ask the judge to look at both, compare, what were the results that were retrieved for each of them, and then maybe ask some, things you should look at or pay attention to based on the experts' feedback. And then in the end, it will say, which one is better.
The way I think about it, right? So pairwise is actually a fairly new idea, at least to me, right? Hadn't really done that until recently. If you've ever gone and gotten your eyes checked and got new glasses, right? And your optometrist is like left or right? Which one is better, right? First one or second one, and they flip it back and forth. It's sort of that same idea, right? We're asking the LLM, do you like the answer on the left or the answer on the right better? And if it works for optometrists, why wouldn't it work for us?
Yeah, so the problem here, or not the problem, but something that will happen is that you can ask for each query, to decide which system is best. But then we start having more variations. You will need to kind of figure out a way to rank them, right? So, why is it not working? Let me just use this one. But fortunately, chess players have figured this out, right? So this is called the ELO ranking system. And the way it works is that for us, each agent is like a player that starts with some initial rank, right? Some number. And then each query, it's going to be a game that is played between two agents. So then for each game, you will ask a judge to evaluate whether agent A or agent B won based on some criteria that you define. So if agent A wins and its ranking is higher than B's, that means that the score of A increases by a little bit and the score of B decreases by a little bit. However, if the A won and his ranking was lower, it means like it was less likely to happen, then there will be a bigger boost, right? So A will have a higher boost on the score, and B also will decrease more. So we had the idea like, okay, let's try to do this for agents, and we actually developed this toolkit called RAGElo, which is also open source. You can check it out through this link. And the way it works is that you basically collect, for a set of queries, pass it through the system, collect the hits that it uses, as well as the answers. And then you pass it to RAGElo, which is going to do two main things. One is to evaluate the relevance of each of the hits based on the query, and then feed that to the next step, which will look at both answers of the systems, as well as the relevance scores from before, and just say which one won based on the criteria. And in the end, you run this kind of ELO algorithm, and you get a list of rank, a rank list of where the top agents is going to be the one that will win the most times. Now, quis custodiet ipsos custodes, which in this case translates into who is actually evaluating the judge. Because it's very easy to kind of get lost into the numbers, but when you really look into it, like winning is nuance, right? So for example, in this case, I'm asking main deep learning researchers in the Netherlands. And so you have two answers, one on the left, one on the right. Interestingly, the one on the right is saying something like, what do you mean by main, right? Because it could be like, is it the most popular? Is it the one with the biggest budget or whatever? And the LLM will explain why it chose B in this case, why it was better, because of a particular reason. But if you only look at that, you may lose the fact that maybe you want the LLM to not reply and just say, just ask the question back to the user and say, okay, please specify what do you mean by main. That might be something you want to do, and then if you look at the data, you will realize, okay, maybe let's choose B as a baseline, and then tweak that so it works as we want. And so,
yeah, so a lot of you all saw this yesterday, right? This gets to this sort of eyeballing idea where we actually want to look at the individual results and kind of understand what is happening, right? So here's a screenshot of the tape and mudding tools query that we did an evaluation yesterday, right? Comparing our baseline with our baseline and title boosting. And you can see that, we learned something in eyeballing that, hey, for the first 4 results, it didn't matter, right? They both do the same. But we actually learned a little bit by looking at this that some not relevant documents on the left were removed and some new relevant documents were added on the right and brought up, right? And so eyeballing, this gives us just a very easy way of looking at what is happening, right? Now, this is a picture of a traditional just search query, right? We did a query, we got some documents back for 2 different configurations. Let's look at it. Could we apply this to what the RAGElo is doing and better understand the LLMs judges and how they're doing their pairwise comparison. Is A better or B better? And bring our, back to the title of this talk, human in the loop. How do we bring our human in the loop back into the process? We bring the human in by using this eyeballing tool to look at these combinations and say, yes, do we agree or not?
So now it's time for a demo. Let's see if it works. So this is an application that we usually use for development of our agents. I actually added a new section, which is called the OpenSearch SRW integration.
Cool.
So on the left here, you can see the configuration of the OpenSearch cluster and some RAGElo configuration. And I think most of you guys are familiar with SRW. So actually, the first part, which is agent configuration, is being pulled from SRW. And you might be surprised to know that these are actually search configurations.
Yeah.
So this is where we start abusing it. And maybe Stavros, close your eyes and cover your ears. So basically, in the search profile, you can actually just put any payload, right? It doesn't have to be as OpenSearch query, a value OpenSearch query.
That's what it's for.
So we kind of abused it in this way. So you can see, for example, this one is saying that it's going to use GPT-4o mini, and this one is going to use 5 mini, and so on, right? So you can store that. So then we can select 2 of them, and then you have the benchmarks. Again, it's being pulled from SRW. These are the called query sets.
Hey, look at that. We got TVs, we got our top 20. You all may recognize that, ESCI query data set and our AI research data set. It's actually kind of exciting to have a non-e-commerce data set to be testing out the SRW tool with. So
in this case, SRW will, of course, do the query on its own, but since we are creating the agents outside of OpenSearch, this is going to use actually the API functionality, so that we are going to do this outside and then push the data into SRW.
Right.
So when I click collect here, it's going to actually go for each of the queries and each of the agents, extract the answer from individual queries. So you can see here, for example, it's saying the trace exists, and that's because we already stored these before into OpenSearch.
Right.
So we're actually using an index to store it, as opposed to maybe something like S3. And the reason is kind of simple, which is it's a limitation of SRW, right? Because if we want to visualize this data, it needs to exist in OpenSearch. So so it's going to do.
And so this is really cool because we have a brand new innovative evaluation approach, and we didn't have to build it into SRW to use it. It's all being done outside, and then at the end of it, the data is gathered and just stuffed in.
Yeah, so if I go ahead and click on Evaluate Pairwise, it's going to run the RAGElo module now, using all of the data that has been collected, and then create a new, what is called an experiment.
New experiment,
That is going to push the metrics, including the ELO ranking, as well as all of the details about the query set that we're using. So in the end, it will display it here, but there is also a link to SRW. So when I click it, you will see something that you maybe saw before, but there is some weird things going on. So can you explain?
Yeah, okay, so obviously we kind of jammed in a very different type of data into the SRW UI, so apologies for some of the formatting, right? But here is one of the experiments that we ran, and I'm gonna, so we have a query set. Can I bring that up?
Yep.
That'll come up, right? And so there you can see there's a whole bunch of queries, right? We have these RAG-style queries that we're using in our experiment. And then, back button. And then we mentioned, right, there are our 2 agents, our 2 RAG evaluations that we're comparing. And there is all the details about it, right? So we are just sort of stuffing that in. Interestingly, and this was super interesting to see, and I'll show you in a second, this is the name of our index that we're storing all of our experiment results. So all of the chunks that we're using to power our RAG solution and the actual answers, it's just another OpenSearch index, and we reference it through that parameter right there so the SRW can look up that data and bring it back. So what are we looking at right in here, right? So we have some classic metrics from doing comparisons, right? Our left and our right. But we've added some new metrics in here. We've added a explanation, right? So one of the things that we kind of learned in playing with doing this is metrics, we sort of assumed were numbers, right? But a metric could also be some text or a label that helps you understand something. And so right there, that is the explanation from the LLM about looking at the left and the right, assistant A and assistant B. And as you can see, there's a lot of text in there. We're also storing at the aggregate level each agent's ELO ranking, right? And so we can see that the agent 2 has a lower ranking than agent 1. Now I'm going to zip down. Anything else on that one?
Yeah, maybe I would just like to point some stuff in the actual
please.
So, because for example, if you remember like the traditional SRW setup, you will have the same amount of hits on both sides. Whereas here, depending on the model and the agent architecture that you choose, it might be that one is actually retrieving hundreds of hits. Right? So in this case, you see there are 111 hits for this one. It's actually GPT-5 mini. And whereas the traditional models, like maybe previous generation models, they will just stick to 10 and then not try again to search for more results. The other aspect is that you see most of them are not kind of related, like both systems retrieve different results. And something I noticed, I actually cannot show you here because it's not part of the visualization, but it's kind of interesting where GPT-5 mini will kind of cheat with the queries. So for example, there was a question about what companies provide multilingual embedding models. And instead of just saying, okay, multilingual embedded models as a query, we'll set that and then in quotes say AWS, Google, and so on.
It expanded it.
Exactly. So
the query.
Depending on whether that's good or not for use case, you need to evaluate. But I think like by surfacing all of these things, you could very quickly see issues or things that you want to.
Do you want to show clicking into the individual documents?
Yeah. So let me just find one that is a bit better looking.
Yeah.
One with the.
And then when you click it, you have to scroll back up to the top.
Yeah, this only a few. But basically, the other thing we had to kind of, hack.
Yeah, hack is appropriate. We had the APIs that we had and the mental models of what the structure was. So we had to work within the boundaries of what we had.
Yeah. So, but basically, in SRW, of course, you're just showing the hits. But here, there is an answer associated with the hits.
Right.
So we kind of hack the first element to be that answer, and then you can kind of scroll and see, maybe it's a bit too small to see, but this would be the answer of agent or like of system A, and the one on the right would be answer of system B. And then below you will see all of the hits that were used and whether there is some overlap, and then maybe how the positions change, so that you can understand, the qualities between the systems.
And so if you're a subject matter expert who understands that domain, you can look at that and say, yes, those citations make sense, or those are good ones, or these citations don't make sense, and get a sense of which ones were pulled in and the quality of the answer.
Exactly. Yeah. And I think that's pretty much it for the demo. I mean, the idea was also to kind of show this explanation of why the judge decided to award, which is the winner here, agent A. But it's hard to see, so maybe we need to think about a different way of showing that, maybe as a different box, or I don't know. But so let me go back to the slides.
So. Yeah, so we worked on this, not a ton, a couple of weeks, maybe. But it was really an interesting experience. We definitely found that one of the things that we were able to do was do the compare two RAG solutions together, right? But one of the things that you saw in the talk was that really, generally, you're comparing more than two together, and that's where the ELO really gets exciting, is when you are comparing 5 RAG solutions, RAG algorithms to each other. And so one of the things, and we didn't try to do this, is in SRW, we do have a concept of an experiment variance, where you would have a bunch of different experiments and they're all related together. We kind of backed into our understanding of that fairly late in the process. I think if we went back and, I think next thing to look at is, does the support for having n number of experiment variants within a single experiment match better what we would want to do for ELO and comparing lots of them? Because really what we just showed you is just 2, and you would have to run a separate experiment for every pair and then sort of awkwardly combine that to yourself. And so, when Fernando saw the experiment variant capability, he's like, I think that's actually what we need. So that would be, that was definitely something that we learned in this process, that if we were to start all over again, that's what we would have based it on.
Yeah. And in terms of statistics, I think for me, RBO and Jakarta are very, very good metrics for kind of sorting what queries you need to pay attention to as a human, right? Coming back to this human in the loop aspect. But I don't think we kind of figure out how to do it for RAG, right? Because RAG is actually an answer, like a long answer. How do you make sure, how do you signal whether you need to look at these 2 answers? Because maybe they are too far apart, or they are, they don't agree with each other.
And you can't sort a bunch of RAG answers and say they're all the same or different, that, so.
Yeah, as well as, for example, the tool calls, right? Which is more like at the internals of the agent. Whether you want to look at, how many tool scores were made and whether they are reading or maybe they are cheating, like we showed in the demo. So I think the fact that we are able to also modify the APIs, I think you submitted some PR for making sure that we can actually just push the metrics from the outside, right? So that's, I think that's good progress. But I think we are also very interested to hear you guys, if you are working on something similar, whether you want to see or use some solution like this, and to see your experiences as well.
Yeah, and lastly, maybe we should have vibe coded the UI, right, for rendering it, and just use the SRW APIs. So terrific.
Thank you.
Thank you. We got time for questions?
How much longer before you have a UI that looks nice?
I mean, honestly, if I just spend a little more time with my buddy Claude, there's a lot. So historically in SRW, we'd always thought about metrics as just being numbers. And then we're like, well, sometimes you want a label. Sometimes you want to see a green, a red, an orange, right? And, I don't know if they're technically metrics in the way we think of them, but they are useful, right? And so that, really kind of came through, and I think we'll need, if you looked at this demo a couple of days ago, you would have seen not a number all over the UI after we uploaded the data. So there's definitely room for that. The other thing that we learned is in SRW right now, we store all the metrics at the per query level and then just average them for the top level. We should probably just support a top level metric that you insert without having to back your way with an average or a sum or any of that from the underlying data, because that fits a lot of other mental models for what an evaluation or experiment should look like.
Yeah, like for example, ELO is not just the average of the per query.
Exactly, right. When it tells you who the winner is, we're actually just averaging a bunch of numbers together. It should be a 0, 1, or a 2, but instead we're getting an averaged version of that, right? So, yeah. Charlie?
Actually, the mixed judge framework is definitely good. But I'm thinking about the usage of this XRW. Currently, that's just for evaluation, or you want that also notation for like a model training or just feedback on the relevance, or you want to make an outline, which means you can judge the real-time outcomes for relevance.
Yeah, I think it's a very good question. And so initially, what we thought is more like, people kind of get lost into the numbers, and then they don't kind of go back and see why the numbers show up the way as they are. So for me, the value of the SRW was to actually just have a way to easily look at it. But I agree. I think I also saw like your demo on the well, you showed me privately, but the hybrid, that you can use that to optimize the model. And we also work at Zeta Alpha. We have this talk next week at a conference where we're going to talk about how to improve these deep research agents on their own. And then you actually use RAGElo as a signal to kind of evolve the systems. Yeah. So I think that definitely there's some future, but it depends on what you guys want.
You could imagine that you have a system that's monitoring your in-production environment and noticing certain issues or whatever, and it just takes it and sticks it in as a, hey, go look at this, and then you could use SRW to click around there, right? As a quick and dirty solution if you didn't want to build your own, right? So back there?
Super good presentation. I actually worked on something similar 6 months ago, but the only reason we didn't take it very seriously back then was because of the non-deterministic nature. So sometimes the output is go answer A is really good, but when I run the test again, I see like answer B is good. And we saw this happen a lot with 4O mini model. So do you think, when you created prompts for evaluating agents, do you see this behavior of non-deterministic evaluation? And do you think this is over LLM that might be the wrong, or is it more of a prompt engineering?
Yeah, definitely we see that. And I think what is nice about this ELO score is that, if you think about just real-life chess players, it doesn't mean that one with a lower rank will always lose against a higher-ranked person. So it could be that it's more likely, but it could also be going the other way. So I think the ELO ranking kind of takes that into account in some sense, because the LLMs are actually playing games against each other many, many times, not just once. So it kind of covers for that. But I do agree that the LLMs in general are not, you cannot kind of reproduce the answers every time. However, I think like they are getting a bit better. I compare back to 2022, like each word you put in the prompt might change the outcome completely, whereas now it's a bit more stable. So I believe that in the future it will become more stable. But for now, I think these type of evaluations kind of hide these details a little bit.
Yeah. Cool. All right. Well, thank you guys very much. Really appreciate it. And if you have any feedback or comments, we'd love to hear it. So thank you very much.
Thank you.